Hello, this is Mr. Collier, and today we're looking at some sampling with and without replacement. So in our first example, box contains 6 red and 3 yellow tickets. 2 are drawn at random. The first is replaced. That's an important word right there, before the second is drawn. Draw a tree diagram to represent the information. Okay. So this is our first draw. We could get red or yellow. And there is 6 red, so 6 out of 9 for red and 3 out of 9 for yellow. Now it is replaced, so the second draw is exactly the same, so it's 6 out of 9. Actually, I'm going to reduce those fractions. Let me just back up. Let's do 2/3 and 1/3 to make it a bit simpler. Okay, so we got 2/3 and 1/3 for the second draw as well. Okay, so that's the tree diagram. It's probably both are red. Well, that's this branch right here. So probably both are red is going to be equal to 2/3 times 2/3, which is 4/9, or about 44%. Both are yellow. Well, that's this branch down here. That's probability of yellow, which equals 1/3 times 1/3, which equals 1/9. And part C, the first one's red and the second one's yellow. That's probably a red-yellow, which is 2/3 times 1/3, which is 2/9, or about 22%. And lastly, one is red and the other is yellow. So that is probably red-yellow plus probability of yellow then red. Okay, so we've got to add those two branches together. Red-yellow is what we had from before, is 2/9, and yellow-red is, well, same thing as 1/3 times 2/3, which is also 2/9. So it's 2/9 plus 2/9 is 4/9, so about 44%. Okay, next we have tickets numbered 1 through 7. 2 of the tickets are taken from a hat without replacement. Okay, without replacement. So they're not replaced, so that's going to change the probability. So for our first ticket, okay, we're going to need... Now, if I were to draw a tree diagram here, I would have to draw 7 branches, and then 7 branches off of every other branch. So that's going to take forever. So this tree diagram is not very appropriate here. But we have to remember that the probability does change because there's no replacement. So let's just work it out without the tree diagram. Probably both are odd. Okay, both odd. Okay, the probability the first one is odd is 1, 2, 3, there's 4 of them. That's the probability the first one's odd. And we have to multiply by the probability that the second one is also odd. So if the first one is odd, now we only have 3 odd ones left. Okay, and the total, oh, so the total is not 9. The total is 7, of course. But after a first draw, the total is now going to be 6. Okay, so actually we can change this to half, and we multiply, that becomes 2 and 1, so it's actually 2/7. Okay, or about 28.6%. So that's part A. Part B, both are even, probably both even. So probably even is 3 out of 7. And for the second one, there's only 2 even ones left, and there's 6 total. So this becomes 1, 3, and these 3's cancel. It's actually 1/7, or about 15%. The first is even, and the second is odd. Okay, so let's work that out. First one is even, is 3 out of 7. Now for the second one to be odd, there's 4 odd ones left, but the total is only 6. So let's start simplifying. 2, 3, and then these 3's cancel. We get 2 out of 7. Okay, probability 1 is even and the other one is odd. So that's the probability of, let's write this, odd even, plus the probability of even odd, because you could get an odd then an even, or an even then an odd. So we're going to add those together. So probability of odd then even. Did we work one of those out already? We already worked out even and odd. So we worked this one out already. That one's 2/7 from before. And odd even, I think it's going to be the same thing, because there's 4 odd ones and there's 3 even ones, so that's going to be 1, 2, so that's going to be again 2/7. So it's 2/7 plus 2/7 is 4/7. Okay, and now let's look at one with a Venn diagram. In a class of 24 students, okay, 10 take biology, 12 take chemistry, and 5 take neither. So let's put that 5 out here. This biology and chemistry. Biology, 10 take biology, 12 take chemistry. Now what happens when I add these all together? I get 22, 27. So I've got 3 too many if I add up all these, because I need 24. So that means there's 3 in the intersection, so there should be 9 here and 7 here. So that's your Venn diagram. So what's the probability? I'll write like this: probability of chemistry and not biology. This is how you can write with symbols. Chemistry and not biology. How many people are in chemistry but not biology? That's 9 people are in chemistry but not biology. So it's 9 out of 24, which is 3 out of 8, or 37.5% if you like. Chemistry or biology. So that's how you write that. Chemistry or biology equals, now this is union, so we just add up all these things in the middle, and we get 19 out of 24. Okay, which is probably 80-something%.